Okay, so this is another sum based on ratio. So we have A is to B as 3 is to 4, B is to C is 6 is to 11. So we have to compute A is to B is to C. So first of all, see the value which is being continued there across both the ratios, B, isn't it? This B is the value which is continued across both the ratio 1 and ratio 2. If you see, B is continued. So A is to B is 3 is to 4. When you compare B and C, it is 6 is to 7, 6 is to 11. So we need to make B common across both the ratios in terms of the values as well. So when you have 3 is to 4 and here you have 6 is to 11. So we have to find a common platform for B, in the sense find the LCM of 6 and 4. So what will be the LCM of 6 and 4? It will be 12. 6 2s are 12, 4 3s are 12. So now the A is to B is what? 3 is to 4, it is given. So we will convert it to a form where B becomes equal to 12. So how to go from 4 to 12? You have to multiply by 3. Okay. So 3 3s are 9 and 4 3s are 12. So 3 is to 4 is equivalent to 3 is to 4 is equivalent to 9 is to 12. Now look at the other ratio, which is B is to C, which is 6 is to 11. 6 is to 11. Again, I need to make B as 12. How to go from 6 to 12? I need to multiply by 2. Okay. So C will also be multiplied by 2. So B is to C now becomes 6 2s are 12 and 11 2s are 22 it becomes. So now you see I have A is to B is 9 is to 12 and B is to C is 12 is to 22. I've got the continuity across the values of B. So now I can write it as A is to B is to C. Can write them together. 9 is to 12 is to 22. It's as good as 9 is to 12 is to 22. So this is a means of comparison. So whichever is common, look at that number, that value, and try to make it as common across both the ratios. Yeah. So whichever element is common, B is the common element here, and so if you have 4 and here you have 6, so try to get them on the same platform, as in try to rewrite them in such a way that the B value is same across both the ratios. So that is the whole idea out here. Okay.